So number 5, longest palindromic substring. Given as string S, find the longest palindromic substring in S. You may assume that the maximum length of S is 1,000. So notice there are actually three keywords here: longest, palindromic, and substring. So longest meaning it's definitely a DP style solution, and palindromic just means, well, you need to you need a way to decide whether this substring is palindromic or not. And substring is the key here. It's different from subsequence in a sense that it's a contiguous part of the string. So, a straightforward way to do this is definitely writing a Boolean method, taking a string and test palin, and then you have string S, and then you basically return true or false depending on the string or the substring you're gonna give it, which is gonna take in from the string itself. So basically just for loops I from 0 up to n, and then you for j 0 up to n, or I to n, and then you basically just test palin as the substring ij, or j plus 1. The problem here with this solution is that this is going to go through on, and then another on. So that's on cubed solution, and we know that since the length is 1,000, this is pretty big, so that's why we should not be looking at this solution. So the DP solution for this is pretty straightforward as well. Basically, the algo or the thinking is that if consider Sij as the as your DP invariant, and then you define Sij, or let's name that DPij, is the depending on the palindromic or not is true if S sub ij is palindromic, or false otherwise. So how do you update this DPij? And of course, once DPij is true, then j plus 1 minus I is your length, or to say that's your from to. So you just want to return the longest of S from I up to j plus 1 for substring. And how do you update this DPij? That's the real question here. So DP on ij is going to be true if S at character I is equals to Sj, and DP I plus 1 j minus 1. So so that's the translation formula, and you have a base case which is DPii, which is the diagonal is always true, and you have another case where if S0 equals to S1, then you have DP01 automatically as true. Or if you're trying to use the translation formula from above, then you can't really deal with this type. Like, it's only one step apart from each other. So let's go ahead and do that. So basically, you just want to initialize a DP. Let me size would be n. So you want to initialize a DP as Boolean, easier. And then for you have two cases here. One is that DPI on the diagonals would be true, and the other one is DPI I plus 1 is true if S dot character at I is equal to S dot character at I plus 1. So here you would also need a extra condition, making sure that you can actually access this character at I plus 1. So now you basically want to go through the loop, and the way you should be doing this is to look at every possible length, starting from position I. What I'm saying is that, for example, if you for int I goes from 0 goes up to n, the real length that you're actually looking at depends on I. Let's call this position j, because this is going to be updated if si is equal to sj first, and then at the same time you need dpi plus 1 j minus 1 true as well, and then in that case dpij will be true. So notice how this is I plus 1, so this current I depending on my next I, but j depending on my previous j. So let's say if you were at position 0 and 4, this depends on 1 and 3. So notice this difference is a 4 and that difference is a 2, so you kind of go backward in a sense, but you always start from 0. So at the end you're looking at 0 up to n, finding the maximum. So prior to that you try to find 0 up to n minus 1, and then just keep going down, and we have handled the base case 0 and 0 and 0 and 1. So now you need for int k equals to 2, k less than n, k plus plus. So now I'm basically just looking at if s dot character at I is same as at j, and dpi plus 1 j minus 1. In that case, this will be true. And what is my j here? And j is really just I plus k. But you might encounter cases where k is really close to n, and then I plus k is going to be over than n. So you want to have a maximum bound, so that's this. So then in that case, once j is n minus 1, you can still access this point. So once this is done, you go through the 2 loops. So this is n and n, so that's like O n squared, and this is like a linear update. So now you just basically return. So notice this is a string return, so you need to set up that as s dot character at 0. Of course, if n is less than 1, I'll just return as here. So this is saying that my re is, regardless which one it is, if there were only one character in it, that is it. So if you were talking about, for example, A, B, C, D, E, then regardless which one you return, it's really just a length of 1. But here, you have a length of 2, so if that were true, and my re would be substring I and I plus 2. The reason is I plus 1 is accessible, and I plus 2 is my unavailable or untouchable index, and substring requires that one to be untouchable. Same applies here. So in this case, I would need a running length of my longest what do you call that? The longest string length. So, and I'll just say, and actually I don't need this. So if read.length is less than j plus 1 minus I need to update it. So that's just one update. So read would equal to s dot substring I and j plus 1. And then I just return read over here. I think this should be good enough. Let's go ahead and submit that. Compile error would at interesting. Stamp submit too soon. Not cool. $23. Every index out of bound. Why? K, I plus K, J is I plus K, so this is pretty weird. Because string dot character should be less than -1, so I wonder which one this is. Which one would be 5? J is math.minimum and -1 I plus K. I don't think there's any problem with those. I plus K. And dp I plus 1 J minus 1. If I were n minus 1, then this would be wrong, right? I think that's what's happening here. I plus 1. Huh? Really? I guess I could do this because I have gone through the 2 length of 1 index anyway. I'm trying to justify why this works. If I were n minus 1, I would add n minus 1, and then j would be n minus 1 as well. So they're both equal, and then this is n and something else. So j minus 1 should be always bigger than I plus 1. That's the problem. So let me submit this first. Okay, so the problem was if I were at n minus 1, then this would have gone out of index. So this is the O(n) square method, and as you can see, it's pretty slow. And people achieving this definitely are using O(n) method. I'm gonna go through the managers algo on a separate video, so stay tuned for that. And that's it for question number 5.